In Module 4 we will touch the topic of designing STEAM curriculum and lesson plans using edutainment. STEAM education is a learning approach that uses science, technology, engineering, the arts and mathematics as access points for guiding student inquiry, dialogue, and critical thinking. ART adds a new dimension, a new area, new topics, ideas, and connections that can be linked with the typical science or professional areas we can find in STEM. STEAM enhances the traditional STEM framework by integrating the arts, which encompasses practices, components, and design principles. Considering the importance of 21st century skills, we can go further and start designing the STEAM lesson, no matter which area or class we teach. The aim of STEAM lessons is not only convey important academic concepts, but also inspire a passion for learning and discovery among students. Let me introduce you the 5 steps to effective STEAM lesson plan. First step is details of the problem. Determine the problem students need to approach, maybe find something similar to help them with a solution. Second is active research. Students need to research how to approach the problem and how to solve it. Do a plan for the solution, what should work and what not. The third is application. Students need to apply their own solution to the problem. Next step is truly important. This is implementing presentation and sharing. Students need to present their ideas to get feedback from other groups, what can be improved, or how others would approach to your problem. It may give them ideas on how to improve their solution. And the last is reflection. Reflect on the lesson and link it to the other problems. Why it is important, did I liked it? If I would do it again, would I do something different? This step is useful for the students, but also for the teachers. We aim to craft activities that resonate with every student, acknowledging their unique backgrounds and learning needs. Our focus is on ensuring each student finds their pathway to be actively involved in STEAM activity. This approach isn't just about education. It's about opening up a world of opportunities and fostering an environment where every learner feels valued and empowered. This is achieved with the creation of an inclusive and adaptive STEAM environment and activities. Activities can be adjustable to various groups of students. Different ages, diverse cultural and social backgrounds, students with different learning problems and conditions. All students need STEAM opportunities. All of them learn more with a well-designed, project-focused curriculum. When teachers design STEAM activities, they should make them in a way to ensure the opportunity for real involvement and success for all students involved. Creating a STEAM lesson. How to start? Firstly, you need to establish clear objectives and determine what you want students to learn. Align the lesson objectives with STEAM goals that encourage critical thinking, creativity, and problem-solving skills. The second step is to choose a relevant theme. Select a theme or problem that is relevant to students' lives or interests and can be approached from various STEAM angles. Then you need to think about interdisciplinary integration. Ensure that the lesson incorporates elements from STEAM disciplines and shows how these areas are interconnected and can be applied to solve real-world issues. If you are lacking ideas for the STEAM activities, some digital tools can be really helpful at this phase. Try to use AI. Chat with AI chatbots about the STEAM activities you can implement. Use the Magic School app to help you create the lesson plan details. Or use Canva Education to provide visually engaging interactive materials. When we have established our learning goals, we need to think how to engage students. Here are some ideas. Try to add hands-on activities. Plan engaging, hands-on activities that encourage students to explore, experiment, and create. This could involve labs, building projects, experiments, or design challenges. Incorporate the design process in your activity. Include the engineering design process to guide students through STEAM projects. It involves the next 5 steps, which can be repeated more times. Ask, imagine, plan, create, and improve. Try to utilize innovative technology, whether it's using digital tools for research and design, coding in mathematics, or incorporating digital art. Integrate arts. This can enhance creativity and innovation within the lesson. Include in the lesson visual arts, music, drama, or digital media to express concepts and ideas. Try to implement problem-based learning and center the lesson around a complex question or problem that lacks a clear, direct answer. This will encourage students to research, hypothesize, and explore various solutions. Always connect the concepts with real-world experience. Relate the lesson to real-world applications that are familiar to the students and give them a sense of purpose and context for their learning. To conclude designing our lesson plan, we need to think about students' presentations. They need to have time to share ideas with other students and teachers, whether with digital presentations, posters, or a speech. Feedback is crucial for further projects and students can learn a lot from them, for example how to approach problem solving, or how it would be better to do it for the next time. Always, after the lesson, is important to reflect on and revise it. Reflect on what worked and what didn't. Gather student feedback, and be prepared to revise the lesson for future iterations. There is always a room for the improvements. Try to be innovative also when it comes to assessment strategies. Develop formative and summative diverse assessment strategies. Do portfolios with students, presentations, reflective journals, gather students' feedback, and give your feedback to them. Think about who can do the assessment. Students can assess each other, but can students also assess the teacher? It can be group assessment or self-assessment. There are a lot of different options. And do not forget, STEAM lesson requires assessing both the content and the skills improvement that were selected and taught. The teacher's role is to guide and facilitate STEAM learning. In the next video, you can see the implementation of the hands-on experiments. Firstly, the teacher needs to choose an experiment. With older and more experienced students, you can conduct more experiments. Divide the students into groups of 3 or 4. If you have a smaller number of students, they can do the activity by themselves or in pairs. At the beginning, the teacher familiarizes the students with what they will learn today and tells them that they will be working independently. The teacher presents a brief introduction to the topic of the experiment based on the related STEM field and the age of the students. It is crucial to adapt the entire activity to your group so that students can participate to the best of their abilities and are all actively involved in the experiment. Take on the role of an observer and assistant, and do not be the one who experiments while the students just watch. Students should think for themselves, collaborate, ask questions, and with the help of your minor tips, come to their own conclusions. Even things that seem simple and obvious to us adults are still things that students need to learn. Hands-on learning, also known as experiential learning, is an educational approach that emphasizes active participation and direct experience in the learning process. Students are engaged in activities that require them to apply the knowledge they are gaining, involving physical activities and the use of tangible materials. Hands-on learning can lead to better memorization and retention of gained knowledge, because students need to learn with trial and error. If something is not working as they want, is this immediate feedback for students that they need to fix something or do it differently. It encourages critical thinking, creativity, and problem solving, all the time connected with real-world relevance. And the most important thing, learning with hands-on experiments is always fun. The hands-on STEAM activities can be done in different settlements. In the classroom, on the floor, in the laboratory, outside the school. It can be done individually, in pairs, or in smaller groups. To get the most engaging STEAM lesson, teachers should always connect it with edutainment, gamification, or game-based learning. On the video, you can see the testing of the hands-on experiment result, electromagnetic spinner. This is a fun experiment that demonstrates the principles of electromagnetism. By creating a simple circuit using a battery, wire, and a magnet, you can make a spinner move without any physical contact. When electricity flows through the wire, it creates a magnetic field, causing the spinner to rotate. All you need is a battery, copper wire or tape, neodymium magnet, masking tape, piece of paper and scissors. Look what happens when all is connected. How exciting! Students can learn several key concepts from the electromagnetic spinner experiment. They will understand how electricity flowing through a wire can create a magnetic field and observe how magnetic fields interact with each other, causing the spinner to move without physical contact. They will learn about experimental method, making observations and drawing conclusions based on their findings. We can give you some tips to help open your mind and find ideas. Do not be afraid, the experiments can be really fun, and even if they are really simple, just go for it. Try to create with students a watermill with wood sticks, spoons and bottle cups. Or what about the balloon rocket? Learn about the air pressure and launch your rocket through the classroom. You will need a balloon, clip, straw, scissors, string and tape. Here it goes. Next fun experiment is creating the hydraulic lift. Try to build a small-scale hydraulic lift using syringes, tubes and water to lift objects of different weights, exploring the concept of hydraulic pressure. How many prototypes can you create? Which one works the best? And when the students are learning about the Stone Age, you can connect it with the experiments exploring different types of stones. Using vinegar or acid, test the content of the limestone and learn how to test the hardness and structure of the stone. At the end, you can conclude the lesson with the differentiation of the natural and man-made materials, or with discussion, what can be made out from stone, and if it is important which type of the stone we use for various uses. The next example of a practical experiment, really connected to our lives, especially in the summer, is testing your sun cream with UV light and tonic water. Do you know that tonic actually glows if you shine the UV light on it? One of the important points of this experiment is that it's actually very easy to do. Pour tonic water in a glass and cover it with a PVC food wrap. Spread the layer of the sun cream on it. When you shine the UV light on it, does the tonic glows as much as before you apply the sun cream or not? If the sun cream is really effective in protecting from the sun's rays, the tonic shouldn't glow. Try out the experiment with different variables. Use different factors. Sun cream of various brands. How thick is the layer of the sun cream you applied on the PVC foil, and so on. Additionally, you can connect the lesson with the students' knowledge about the sun and the impact of sun rays. Discuss with them which are the sun rays that are harmful for our skin and why. In this way you can pass them the knowledge how important it is to protect our skin from the sun. At the last, we will present you a colorful experiment. Do you think we can color the flowers? Or is better to ask ourselves how the flower drink water? Use the food coloring and the freshly picked up flowers. The experiment will work the best if you choose white ones. Look what happened with our snowdrops. They become colored. There are several options to interconnect the lessons with multiple disciplines and topics. Ask your students, they can give you a lot of valuable ideas and feedback. And open your eyes and your minds to find new ideas for the hands-on activities anytime and anywhere. Finding the right strategy for your group of students is the challenge you need to face. This will lead you all to an unforgettable STEAM learning experience.